and we march onward through our look at various techniques of integration. We've looked at integration by parts. We've looked at integration of powers of trig functions. And now we look at integration by what's called trig substitution. And it is very triggy, even though when you look at the questions, they don't appear to be triggy. So let's see. So if I'm taking notes, how do I help you to take good notes? Okay, here's the situation. The situation is that the integrand, meaning the thing inside the integral, the integrand, has the square root of x squared plus a number, or it has the square root of x squared minus a number, or it has the square root of a number minus x squared. That's the situation. The solution is to build a right triangle with the radical as one of the sides. That's the solution. We're going to build a right triangle because this looks Pythagorean. This looks Pythagorean. This looks Pythagorean. So build a right triangle. There's a four-step process. The 4 steps work every time. I will spell out what those 4 steps are, and we will do this thing. Find the integral of square root 1 minus x squared dx. Integral square root 1 minus x squared dx. So this is one of those things. It's a number minus x squared. It happens to be a perfect square minus x squared. That's helpful. And so step 1 is to build a right triangle. That will always be step 1. But not just any right triangle, a right triangle where this is one of the sides. And I'm going to make it this side. I know it can't be the hypotenuse. It can't be the hypotenuse because that's not a plus. That's got to be a plus for this to be the hypotenuse. If this is a leg, then the other 2 sides are these squares. Right? 1 squared, x squared. So these are squares of the other 2 sides. So we've built a right triangle. Step 2. Sub for every expression involving x. So how do we do that? Well, we figure out 2 relationships over here, and we use this angle, call it theta. We're going to depend on 2 relationships here. One is the relationship between x and the number. The other is the relationship between the radical and the number. We're going to figure out the relationship between x and the number, the relationship between the radical and the number. Based on right triangle trig, this is cosine of theta. Based on right triangle trig, this is sine theta. Why do we do that? Because the radical is 1 times sine theta. dx depends on what this is. If x is cosine theta, dx is minus sine theta d theta. So dx is minus sine theta d theta. Well, what's that? That's minus sine squared theta d theta. And you learned in our last lesson how to integrate this even power of a trig function. So step 3 is to evaluate the integral. So how do we do that? Sine squared theta is 1 minus cosine 2 theta over 2. And so the integral, so that's, oh, I can do this. I can do this. Just split it up. Pull the 1/2 out. That's -1/2 times theta minus 1/2 sine 2 theta plus a constant. So step 4 is to back substitute. Back substitute. How do we back substitute? We go back to the picture. Need theta. What's theta? That's theta. Maybe I want to get this theta by itself. How do I do that? Well, if the cosine of theta is x, then theta is the inverse cosine of x. Theta is the angle whose cosine is x. What's this? Well, sine 2 theta from all of my work in high school is 2 sine theta cosine theta. So I can do that. To sine theta, we've got that. Cosine theta, we've got that. And we just multiply them together, and we've got it. There is nothing here that you can't do. You can build a right triangle. You can make substitutions. You can do the integral. You can sub back in. There's a lot of places to make mistakes, but it is doable. I will illustrate twice more. But the process is the same. This is the integral of 1 over x squared radical x squared minus 9 dx. 1 over x squared radical x squared minus 9 dx. Again, this looks Pythagorean, so step 1, we're going to build a right triangle. And that right, oh, whoa, so sorry. That right triangle is going to have an angle here. This is not the hypotenuse because that's not a plus sign. And then the other two sides are the square roots of these. X squared, 3 squared. Why do we do that? Because step 2 says we substitute for every occurrence of x. How do we do that? We find the relationship between x and the constant, and then we find the relationship between the radical and the constant. The relationship between x and the constant, that's secant. Why do we do that? Because x is now 3 secant theta, whose derivative is 3 secant theta tan theta d theta. The radical over 3, well, that's tangent. That's just opposite over adjacent. So substituting, this is the integral of 1 over x squared times the radical dx. A complete change of variable. The x gets replaced, the dx gets replaced, the radical gets replaced. And then we hope beyond hope that this thing simplifies nicely. tan theta goes, 3 goes, secant goes with that. So it's important to figure out what's left. There's a 1/9 that I'm just going to pull out for convenience. This is all gone. This is all gone except for an over secant theta. Wait a minute. What's 1 over secant theta? That's 1 over secant theta. Can you do this integral? Oh, yes, and it's probably not even too bad. So then we just back substitute. What is sine of theta? Well, sine of theta is opposite over hypotenuse. And you got it. That was almost nicer than example 1. I will illustrate one more time. One more time. So this will be the integral of x squared over 1 plus x squared dx. So this doesn't have a radical in it at all unless you look at this as that. And in that case, this lies on the hypotenuse. So step 1, we're going to build a right triangle. That right triangle is going to have some angle of interest, and this is going to be the hypotenuse. And then the other two sides are the square roots of these. Stop saying that! I will when you get it. So this helps us to do step 2. Step 2 is to do a complete change of variable, and we do that by taking two relationships, the relationship between x and the number, and the relationship between the radical and the number. X over 1, that's tangent. Radical over 1, that's secant. Why do we figure out what x is? Because we want to know what dx is, and I know what the derivative of tangent theta is, and so do you. So we do a complete change of variable. X squared, that's tangent squared theta. The radical squared, that's the radical squared. Dx, that's this. And those cancel. So when we go to do step 3, this is the integral of tangent squared theta d theta. And I don't have to look far in my notes to figure out that that's this, and that's very doable. Which takes us to step 4. And in step 4, we back substitute. What is tangent theta? Tangent theta is x. What is theta? Well, theta is the angle whose tangent is x. And we got it. The process is the same every time. The integrals are sometimes easier to do than others. Example 1 was a nightmare. Example 3 is not bad. But each time the question is, what are we doing here? I want to give you a couple of things to practice with. One of them is the integral of x squared over radical 9 minus x squared. And the other is the integral of 1 over x squared radical x squared plus 4 dx. Those are things for us to think about, and our 15 minutes are up.